Good morning, friends. My name is Professor Deepak, working as Assistant Professor in Mechanical Engineering Department, LD College of Engineering. We have already studied about the introduction of elements of mechanical engineering chapter. Today we will discuss about IC engines. Okay. The topic today I will cover are engines and IC engines, classification of IC engines, engine parts and their functions, important terms used in IC engine, working of 4-stroke and 2-stroke petrol and diesel engine, petrol and diesel cycles, and performance parameters. Already we have seen prime movers in an introduction chapter, in which we have studied that any device or object or machine or engine which is using natural source of energy and converts into mechanical engineering are called prime movers. One of that prime mover is engine, and we will see today number of engines, and specifically our discussion will be on IC engines. So in figure you can see that I have put several figures over here. When engine comes into our mind, the first figure is this engine, that is a locomotive engine. We understand this is the engine and we speak like engine. If you see beside, we are having another figure which is called gas turbine engine, which is normally used in aerospace industries. Next figure, if you see here, the third figure, it is stationary engine actually, and which is used in a pumping work of farm. So engine is a stationary which is used for different application. Here it is for pumping purpose. And if you see the last figure here, I have two figures over here. One is car visible to us and second is a locomotive engine. The basic difference between here is one engine that is called locomotive engine is external combustion engine, where combustion process take place outside engine and it is utilized to convert into mechanical work. While if you see the car, the next figure here is automobile, where engine itself is a movable, right? So today's our topic is internal combustion engine, IC engine. As we already discussed that engine which converts any available form of energy into mechanical. So any device which will use natural source of energy and convert into mechanical work is called prime movers, or it is engine. If the available energy it is in form of heat, then we call it is a heat engine. So our IC engine is actually a heat engine in which we are using any hydrocarbon fuel just like petrol, diesel or gas. So when we burn it, the chemical energy will be liberated, and this energy liberation is used to convert it into a mechanical form. So this engine is called internal combustion engine. So now let us see the definition of IC engine. An internal combustion engine is a device in which the chemical form of energy is released inside the engine and used directly for the mechanical work. Some examples I have written over here, that is a piston engines, means you can see any automobile, your car engine, bike engine, scooter engine are the IC engine. So piston engines. Second is gas turbine engines, which we have already seen on a first figure, that gas turbine aviation purpose the engines are using gas turbine, that is also a IC engine. And third is a rocket engine. Now let us start the topic with classification of IC engines. The IC engines are classified in a different way. As I said that IC engine stands for internal combustion engine. So now we will discuss only about the internal combustion engine. We will not touch the external combustion engines. So let us start classification. The first classification is based on the fuels. What kind of fuel we are using, that are first is petrol engine. So normally all bikes you see, if you see, you are having a small engine which is run by a fuel that is called petrol. Then second fuel is a diesel engine. So in fuel, if you are using diesel, then it is called diesel engine. Normally cars, we can see the diesel engine cars. Normally bikes are not available in a form of diesel. Normally I am speaking. Third is a gas engine in which we are using gas as a fuel. It can be a LPG, it can be a CNG or any other fuel. And fourth is a biofuel engine in which we can use two fuel as our fuel. Next classification is based on the nature of thermodynamic cycle. In introduction we have studied something about the cycles. The first cycle, thermodynamic cycle on which IC engine work is a Otto cycle. This Otto cycle is actually used for a petrol engine, means SI engine. What is SI? Spark ignition engine, we will discuss here. But first is Otto cycle. Second is a diesel cycle. If your working fluid is a diesel, then the cycle is diesel cycle. And third one is a dual or mixed cycle, in which it will be a combination of Otto and diesel. We will see the different cycles there. The next classification is based on number of strokes. Either 4-stroke engine, first is 4-stroke engine and 2-stroke engine. Now it is important to understand what is actually a 4-stroke engine and what is actually a 2-stroke engine. As we see that engine is used to get the mechanical work, right? So when we supply the internal energy as a chemical and heat, and when we convert into a mechanical form, how it will be converted, that is important. So we have two systems over here. One is a 4-stroke engine and second is a 2-stroke engine. 4-stroke means the engine will take fuel in, then combustion process will take place, heat liberation will take place, and then we utilize it into mechanical work. So in that 4-stroke we are having suction, that is inlet, where fuel and air mixer in case of petrol, and in case of diesel engine, diesel will be injected into that. Now air will be taken in an engine cylinder. Second stroke is compression stroke. So fuel will be compressed at higher pressure. The third stroke is expansion. After compression there will be ignition, then it will be combustion process will take place, and the high pressurized gas will exert some pressure onto a piston. So again piston will move down. So third stroke is called expansion stroke or power stroke, which is useful. And fourth stroke again is exhaust stroke, means after expansion, power stroke, now the burn gas, flue gases should go to atmosphere. So exhaust stroke will start and flue gases will go into atmosphere. Next class, the second is a 2-stroke engine. In 2-stroke engine, same thing will happen: inlet, compression, expansion and power, but this will happen simultaneously. Suction and compression happen simultaneously, and power and exhaust will happen simultaneously. That is why it is called the 2-stroke engine. The basic difference is, in 4-stroke engine, out of 4-stroke there will be a 1 power stroke, and in case of 2-stroke engine, in a 1 revolution of crankshaft there will be a 1 power stroke. Next is the method of ignition. First is spark ignition, SI engine. SI stands for spark ignition, and second is a compression ignition engine, that is called CI engine. Spark ignition engines are actually petrol engines, and compression ignition engines are actually diesel engines. Next classification is based on method of cooling. How, when heat is liberated into an engine, some heat energy will be converted into a mechanical work. Then remaining heat has to be liberated to the atmosphere. So for that we require cooling mechanism. In cooling mechanism, when we liberate heat to the atmosphere, we are having two kind of system. One is air cooling system and second is liquid cooling system. So liquid can be a water or any liquid. Now water is not normally used, the coolants are used, but these are two main function: air cooled and water cooled. Now what is the basic difference in a construction of air cooled engine and water cooled engine? If you see your bike, just take example of Hero Honda Splendor. It is having engine visible to you, right? In engine you will find number of extended surfaces that are called fins. These fins are provided to release the heat into atmosphere. So that is called air cooled engine. In case of larger engines where power production is more, then air will not be sufficient to cool it. So in that case we are using coolant or water circulated around the engine so that the cooling effect take place. Next is classification is based on method of governing. The first method is quantity governing, which is used in petrol engine or SI engines. Second is a quality governing system, which is used in diesel engine or spark ignition engines. Now let us understand what is quantity governing and what is quality governing. As in school chemistry you have already studied that any hydrocarbon fuel has to burn when? Then oxygen is required. So when oxygen and hydrocarbon will be in a proper mixture, the combustion process will take place. So that is we call is a stoichiometry air fuel ratio. So for complete combustion of any hydrocarbon fuel, what amount of oxygen we require, we calculate it, and then the ratio what we are getting is called stoichiometry air fuel ratio. So in petrol engine we are having stoichiometry air fuel ratio is 14:1. So 14.5% air is required to complete combustion of one unit of petrol. So in a petrol engine, one carburetor is used, that is a device which will mix air and fuel before it gets into a cylinder. So air and fuel is mixed in a carburetor at a particular setting. Suppose it is a stoichiometry air fuel ratio, then it will be a 14.5:1 ratio. Now suppose you are using your bike at some certain speed, suppose 40 km/h speed you are going, and suppose now you want pick up more, means you want to accelerate your device, you will throttle it, means accelerate it. So your requirement is more power. So how this more power will come, means air fuel ratio is fixed, so when you accelerate it, more amount of fuel will enter into your combustion chamber, so more energy will be liberated, and that will be converted into mechanical work. So this is called a quantity governing. The quantity is fixed, not fixed. When you give acceleration, the quantity varies. When you throttle it, the amount of air fuel mixture will go in a variable quantity. So that is why in petrol engine, the governing system which we are using is called quantity governing, which is used to get a different power at different conditions. Now come to a second, it is a quality governing system. Now in quality governing system, you can take just simple example that you are having a 1 glass of rasna. There should be a proper mixer. If water amount is more, then the taste will be a different, and if rasna amount is more, then the taste will be a different. So it is called quality. So if you want to maintain constant quality, there should be a constant proportion. If it will vary, then the taste will vary. Same kind of phenomena will happen in case of diesel engine. When you want to burn diesel, the in suction stroke only air will get into a cylinder, and then diesel will be mixed into. So when your power requirement is more, when you give acceleration, more amount of diesel will be injected into that. So quantity of air is fixed and diesel quantity varies. So quality will be a different. When your acceleration is in lower position, the diesel quantity injected here will be a different, so the quality will be a different. So in diesel engine, the governing system according to your load requirement is a quality governing system. Next is speed of engine. Now speed of engine is, we have a classification on low speed engines, medium speed engine, and low speed, medium speed, and high speed engine. Now petrol engines are normally high speed engines, and diesel engines are low speed engines. So when you start your engine, actually engine is nothing but it will convert the reciprocating motion into rotary motion. So when you measure the RPM, revolution per minute, if it is high, it is called a high speed engine, and if it is low, it is called low speed engine. Next classification is based on number of cylinders. It can be a single cylinder engine, or it can be a multi-cylinder engine. Now let us understand what is single cylinder engine and what is multi-cylinder engine. If you see your bike engine, it is having so small engine, small cylinder visible to you. So the power production requirement in case of bike is very small compared to your car. Your car having weight more. Suppose I take a simple example, my bike having 100 kg weight, while if you compare a normal car, commercial car, it is having around 1000 kg of weight. So first is weight is different, so load on engine is a different. So when your power requirement is different, we go for a different cylinders. So when small power engine we require, it is called single cylinder engine and normally used in a bike. When power requirement is more, we are using multi-cylinder engine. Say you take example of your car, it can be having 3 cylinder, 4 cylinder, 6 cylinder, or more than that according to load requirement. So this is what the classification, number of cylinders, single cylinder or multi-cylinder. And last classification is based on position of cylinder. How you are putting the cylinders. If it is a multi-cylinder engine, what will be the position of cylinder? That is the classification. So inline cylinders. If you open a car bonnet, you will see number of cylinders. Suppose it is a 4-cylinder car, you will find cylinders are in a series, one beside second, then third, and then fourth. So this kind of arrangement is called inline engine cylinder. Second is V engine. So V engine, if your engine cylinder shape is like V, just like your V, alphabet V, then it is called V engine. Next classification is a radial engine. Radial engine means cylinders are put into a radial fashion, circular fashion, so that there will be a number of cylinders into a circle. The position is in a radial, so it is called radial engine. Next is opposed cylinder engine and opposed piston engine. So it is a position. Opposed means the number of cylinders are in opposition. So one is in left, then opposite will be in the right side. But piston movement will be the same. And opposed piston means piston also will move in a different. If one piston is moving in left and opposite system is moving in right, then it is called opposed cylinder engines. So this is what basic classification we have discussed here about IC engine. Now, construction. If you see the IC engine, we are having number of components. In this figure, the number of components are visible to us. You can see here the construction detail. Let us start with this one: the rocker arm, spring, cylinder head, injector, push rod, inlet valve, cam follower. These are the different components. Let us start with the basic first component. If you see your engine, the basic first portion which is visible is called cylinder. Right, on which, as I given the example of your bike engine, in which the number of extended surfaces are there, that is on a cylinder. So this is the cylinder portion you can see here, in which we have number of components. So it is you can say that it is the outer body of your engine, in which number of component you can fit. Now come to this portion that is called piston inside. So this is the cylinder, this is the volume inside. One component is reciprocating. As I said, that engine is converting reciprocating motion of piston and connecting rod into rotary motion of shaft. So actually we are getting output is in rotation. So piston is a device, this one is a piston which will move up and down here in this. It is connected with one another component that is called connecting rod. And this connecting rod is connected with one other component is called the crank. So actual mechanism is called the slider crank mechanism. The sliding device is my piston, connecting device is connecting rod, and then it is connected with the crank, so that the reciprocating motion of piston will be converted into rotary motion of the shaft. So piston will move up and down over here. Now on piston, this one is piston pin. Piston pin is nothing but it is a component which will connecting rod with the piston with help of piston pin. You can see here the piston rings are also mentioned over here. The piston rings are nothing but two kind of piston rings we are using, in which one is compression ring and second is oil scraper. So whenever your pressure here after the spark or combustion, when pressure is more here, while here the bottom side of piston your lower pressure is very lower, so there should not be a leakage of pressure from higher pressure to lower pressure side. So compression ring will fulfill that function. It will not allow to leak pressure from higher pressure to lower pressure side. Then here you can see that lubrication oil I have. So whenever your piston is moving with very high speed, it requires lubrication also. So the lubricating oil will be splashed over here. It is called splash lubrication system. So it should not go into a combustion chamber. So for that we are having one ring that is called oil scraper ring, which will clean the cylindrical surface. Now in this particular figure the water jacket is visible. So it is actually a liquid cooling system. It is not an air cooling system. So particular water word is written over here, but nowadays no engine using water. It is called coolant, but it will be circular. Outside of your cylinder you can see the jacket is provided in which the water is circulated or a coolant is circulated, so that whenever heat is liberated over here, it will be converted into a mechanical work, and remaining heat will be taken, some amount of remaining heat will be taken by this water or coolant. Then you will come to here, I have a two component that is called cam and cam follower. Now as I mentioned in a 4-stroke engine, the first is suction, second is a compression, third is power or expansion, and fourth is exhaust. How it will happen? So you can see here I have a number of valves. So this valve visible to you is called inlet valve, and opposite side this valve visible to you is called exhaust valve. So when suction will start, the piston will move downward direction, it will create suction, and this valve will open. So to open and close this valve, I require some mechanism. So for that I have a cam and follower mechanism. You can see the shape of cam. When it will move up, the follower will rise. It will push this rocker arm. This is the push rod, and this rocker arm is connected with the valve. So when it will move up, it will push this valve into downward direction, so it will open. So suction will happen. Same way for exhaust valve operation, I have a opposite side, same mechanism, cam and follower mechanism, push rod, rocker arm, and it is connected with the spring. So these are the basic components which are important to understand the construction and how it works in an IC engine. Now let us start with the terminology. Terminology means different terms we are using when we talk about the IC engine phenomena. One is a bore, second is a stroke, third is a dead center, fourth is a clearance volume, and fifth is a stroke volume or swept volume. So assume that this is my cylinder and this is the inside diameter. So inside diameter is called a bore. Whole diameter, it is called diameter, so it is called bore. Now normally we speak in engine like that what is the cc of engine. Normally we speak like that, cc. Cc is nothing but the volume inside of your cylinder, that is in centimeter cube. So centimeter cube short form is cc. So when we use cc engine, it will be a volume, and as it is a cylindrical, so you can calculate using an equation, and diameter you can get. So whatever diameter you are getting, that is called a bore. Second term is a stroke. Now as I said that suction, compression, power and exhaust will happen. How it will happen? So stroke will happen, you can see here stroke. Now my piston, this blue color line indicates that my piston is somewhere over here. Now when suction will start, piston will move down and it will come to over here. So when it will move down, the maximum position uplift, uppermost position is this and lowermost position is this. So when it will move up to down, whatever volume it will cover and the length it will cover, that is called stroke. So this length, highest to red color line indicates that the highest position line and lowest position line is called the stroke. Now the dead center. If my piston is in a vertical engine, if my piston is at the topmost position, it is called top dead center. So short form is TDS, top dead center. When it will start move, the minimum limit or extreme limit of lower side, when it comes to a red color line over here, it is called the bottom dead center. So short form is BDC. So in vertical engine, TDC and BDC is used to indicate the piston position. Fourth is clearance volume. In this particular figure you can see here, this is my cylinder head, means the extreme line of my cylinder, and this is the line of my piston. In between you will find some gap over here. This gap is called this gap is there, and if you calculate its volume, it is called clearance volume. And stroke volume or swept volume is the volume covered by the piston movement from top dead center to bottom dead center. Now terminologies, the swept volume is mentioned over here, that this is my cylinder. Now 3D diagram if you see, this is my cylinder and the piston is somewhere over here. The movement will happen, it will show you how the volume is changing from top dead center to bottom dead center. Now let us concentrate on a two main parameter, that is 4-stroke engine and 2-stroke engine. So first we will discuss is 4-stroke engine. As already I have mentioned, but systematic way we will see now is the first stroke is suction stroke. Suction stroke means suction or inlet will happen. So air and fuel mixer in case of petrol and air in case of diesel will get into engine, that is called suction stroke. Next stroke is compression. Once your fuel is get into your engine, the compression process will start. So piston will move from bottom dead center to top dead center. So your confined volume will be compressed. So volume is fixed and your charge, that is either air fuel mixer or only air, will be compressed. So that is called compression stroke. Third stroke is expansion stroke or power stroke. After compression, in case of SI engine, spark will ignite and the combustion process will start. So air fuel mixer will burn, and when it will burn, it will create tremendous pressure and temperature, and that force, it will apply some force onto a piston, so that piston will move downward direction. That is called power stroke. So first and second stroke, that is suction stroke and compression stroke, are power consuming stroke. We have to give some motion so that it will move. Only third stroke is a power stroke, in which we are getting energy output from the engine. So that is third stroke, that is called power stroke, or we call it expansion stroke. And fourth stroke is exhaust. After completion of your power stroke, now I want to release this flue gases into atmosphere. So you can say fourth stroke, in which the exhaust stroke, where flue gases will be released into atmosphere. Now how? The suction inlet, how it will happen, and exhaust, how will happen, it depends on a valves. When we want suction, then inlet valve should open, air fuel mixer should get in. Now I want to do compression. If I want to do compression, then my suction valve should in off condition. So in suction stroke, inlet valve is open, air fuel mixer or air will get into a cylinder, then it will stop. So when piston will move from top dead cell to bottom dead center, it will create some vacuum, inlet valve is open, so air and fuel mixer will get in, or air will get in case of diesel engine. Then valve will be in off condition. So first stroke is over, that is suction. Now second stroke, piston will again move from bottom dead center to top dead center. Now both valve in a closed condition, so volume is fixed and piston is moving upward direction. So compression process will take place. So charge is compressed. When it will be compressed, the pressure is more increases and temperature is increases. Now in case of petrol engine, the spark will ignite and it will burn the fuel. In case of diesel engine, fuel injector will inject the diesel particles, small particles of diesel into engine, and the combustion process take place. When combustion takes place, now high pressure, high temperature will apply some force onto a piston. So again piston will move from top dead center to bottom dead center. When it moves top dead center to bottom dead center, it is getting energy from the flue gases, chemical energy, heat energy. So it is called power stroke or expansion stroke. Now, after reaching to bottom dead center, now fourth stroke is exhaust stroke. Now piston will move up, the exhaust valve I should open, so exhaust valve will open, piston is moving out, so flue gases will go into atmosphere. So these are the four strokes. Now let us understand theoretically and figure wise, so it will be clear to us. First stroke, suction strokes. You can see here I have an inlet valve and I have an exhaust valve. Initially both are in a closed condition and my piston is at top dead center. Now first stroke when start, now piston will start moving downward direction. So red arrow indicates that the piston is now moving in downward direction. So if two valves in a closed condition and piston is moving downward direction, it will create some vacuum. Now here the pressure compared to outside pressure is less. Now I want to get in the fuel, that is either air fuel mixer or air, the inlet valve will open. So you can see the position over here that when piston is moving downward direction, my inlet valve is in open condition. So when it opens, the air fuel mixer will get into this portion. So this is the volume it will fill. It will continue moving down, the piston will continue moving down from top dead center to bottom dead center. So second figure you can see here, it is still moving downward direction, so more amount of air fuel mixer will add, and finally it will reach to the last position, that is called the bottom dead center. So whole volume here is filled by a charge, either air fuel mixer or air. Once it will reach to a bottom dead center, now my valve in a closed position. So now both valves are in closed position, so my volume is confined. So suction stroke is over. Now second stroke will start. The position in suction is top dead center, piston has moved from top dead center to bottom dead center. Now second stroke will start, where my piston will move from bottom dead center to top dead center, let us say. So now compression stroke, both valve again in a closed position and my piston is moving from bottomward to upward. So now confined volume is decreasing as piston is moving up. So when volume is decreasing, the pressure is increased over here. So piston is moving up and the pressure and temperature inside is increasing. So finally when your piston will move from bottom dead center to top dead center, the whole confined volume will be in the clearance volume itself. So there will be a high pressure and high temperature. That is called compression stroke. After compression stroke, when my piston is at top dead center, now you can see here the spark will ignite. If it is a petrol engine, here is a spark plug. So spark plug will ignite the fuel and the combustion process will take place. As combustion process will take place, the energy will be released, and now there is no space to go this energy. So what will happen, the pressure and temperature will tremendously increase and it will exert the force onto a piston, and the piston will start moving downward direction. So here in this figure it is shown that the induction of sparks at the tips of the spark plug in case of SI engine, spark ignition engine. If it is a diesel engine, then instead of spark I will have spark plug, instead of spark plug I will have an injector. So the injector will inject the small particle of diesel into engine, and the pressure inside and temperature is such that when it will be injected into a cylinder, automatically combustion process will take place and then it will exert the pressure over here. So after compression, either in SI engine spark will ignite and combustion process will take place, and in case of diesel engine the fuel injector will inject and combustion process will take place. Next stroke is a expansion stroke. Now after combustion, as I said that high pressurized, high temperature flue gas will exert pressure onto this. So now again my piston will move from top dead center to bottom dead center. So this is called expansion stroke, and that is also a power stroke which is delivering the work output from the chemical energy or heat energy. So third stroke is an expansion stroke. Piston is moving down. Here the red color indicates high pressure, high temperature, and it is moving down. You can see here. So again top dead center in power stroke, your piston will move from top dead center to bottom dead center, and whatever energy is liberated over here, that will be converted into a rotational speed of shaft. Fourth stroke, that is exhaust stroke. Now after third stroke my piston is at again bottom dead center. So all energy is converted into rotary motion of shaft. Now I want to release this flue gases into atmosphere. So how to release? Both valve in a closed position right now. So if I have to release this flue gases into atmosphere, I have to open this valve. So in a fourth stroke, as piston is moving from bottom dead center to top dead center, when it is moving up, you can see here the valve is in an open condition. So when valve is open and piston is moving up, so piston is pushing this flue gases into atmosphere. So flue gases will go into atmosphere till the piston will reach to top dead center. So now after this all four strokes, suction, compression, expansion and power, the piston movement, I am repeating that initially piston is at top dead center. Suction, it will reach to a bottom dead center. Compression, again bottom dead center to top dead center. Expansion and power stroke, it will go to a bottom dead center, and again fourth exhaust stroke, it will come to here. After fourth stroke, again the same procedure will start. Piston will move down, inlet valve will open, and whole cycle will be repeated. So you can say that in a IC engine, 4-stroke engine, out of 4 stroke, only one is a power stroke. Suction, we have to give power. Compression, we have to give power. Expansion or power stroke, we are getting power from this, and exhaust, again we have to give power. So if I have during 4 stroke only 1 stroke is a power stroke and remaining 3 are power consuming stroke, how to manage this energy? So energy utilized in suction, compression and exhaust can be utilized from the energy output we have got from a power stroke. So for that we are using flywheel, one component which is connected with the crankshaft. When piston is moving up and down, it is converting into rotary motion of shaft. On shaft I have a flywheel. Flywheel is a device which is called the energy storage device. So when in power stroke your power production is very large, it is connected with the flywheel is connected with the shaft, so it will store this energy and it is rotating. So when in remaining third stroke, suction, compression and exhaust power is required, some amount of energy flywheel will supply to a engine. So that is why if you see a normal condition when you start your engine, say bike, if you take example of your bike, when you start your bike, you have to make a kick. So you are applying force onto a piston so that the motion will start. Nowadays we are using electronic system, means you are having a starter, electronic motor connected with the cranking. So normally we call it a cranking. So you are supplying electric supply and power, actually nothing but power, so that your section will start. So this is what power input you require. So once your engine is started, your power stroke is, you got the power stroke. Now you need not to give the power manually because it will be fulfilled by the flywheel itself. Now I have explained 4-stroke petrol engine. Now let us see 4-stroke diesel engine. So all figures I have put on one diagram so it will be clear to understand. Say here it a inlet valve. When piston is moving down, arrow indicates that piston is moving from top dead center to bottom dead center. The valve is in open condition and blue color indicates that fresh charge is getting in. So in case of diesel engine, my fresh charge is nothing but air only. So piston is moving down. Your crank rotation, you can see it is rotating in this direction. It will get in, and when it will reach to bottom dead center, your suction stroke is over. So this is a suction. Now come to a second stroke, that is called compression stroke. Well, both valve, inlet valve and exhaust valve in a closed condition, and piston is moving up. So you can see here the random position of molecules here are in confined volume. At volume is decreasing, so pressure and temperature is increasing. When it will reach to a top dead center somewhere over here, now fuel injected. Instead of spark plug, in case of diesel engine we are having fuel injectors. So it will inject fuel into that, and that fuel will be injected into a small droplet form. So when it will get into an engine, the temperature and pressure is such that the combustion process will start and it will liberate the energy. So when it will liberate the energy, again the power stroke will start. So piston is moving downward direction, force is applied. So this is the power stroke. We are getting the power from the combustion of fuel. It will reach to a bottom dead center. Now fourth is exhaust. Now I want to release these flue gases into atmosphere. So now you can see in this figure that exhaust valve is in open condition. So that piston is moving from bottom dead to top dead center. The flue gases will go out. So these are the 4 strokes: suction, or it is called intake, compression, power and exhaust in case of diesel engine. Now let us see the animation, so it will be clear to us. It is a 4-stroke petrol engine animation. You can see here the blue color indicates that it is a fresh charge. So the piston is moving up and down. You can see here the inlet valve when opens, the fresh charge getting in, compression happens, spark plug is sparking, so the combustion process will take place, and finally is exhaust. So exhaust valve is shown as a red color because after combustion the temperature is very high and it has to liberate it into atmosphere. So color code is also important here. The blue color is fresh charge, red color is the flue gases, and the mechanism happens. Now as I said that in IC engine the reciprocating motion is converted into a rotary motion. How? You can see in this particular animation. The reciprocating part here is nothing but piston only. It is connected with the connecting rod, and then it is a crank. So this mechanism, when it is moving up, the white color shaft you can see. So all motion, reciprocating motion is finally converted into a rotary motion of shaft. Because if you use your IC engine for automobile purpose, your requirement is to rotate the wheel. So the rotating speed you are getting by conversion of reciprocating speed into rotary motion. Now in different kind of arrangement of cylinder, we discussed that inline cylinder arrangement. You can see here it is just animation of, suppose, a car engine in which I have number of cylinders are 4, 1, 2, 3 and 4. And as I said that there are a flywheel which is connected on the crankshaft. So this is the crankshaft and I have a flywheel over here. So inline engine, multiple cylinder engine where power requirement is more. You can see here when spark here it is having in a different cylinder options. So one, it starts here, then in a third. So we can take 1, 3rd, 4th and 2nd. So power stroke happens in this way: 1, 3, 4 and 2. This is the ratio. Now all is producing power in a different stroke. Here it is producing power while other is consuming. So all power output is shaft is converted into rotary motion of shaft, and it is connected with the crankshaft flywheel. So all the power is stored by flywheel, and in remaining stock it is supplying energy to the piston. Now this animation shows the 4-stroke diesel engine. The animation is just simple, only the change in a component is this one. In previous case it was a spark plug. In case of diesel engine I have a fuel injector. So it will inject the fuel, diesel, in a small partlet and the process will start. Okay. So we have discussed this 4-stroke engine. Now let us come to 2-stroke engine. See, the 4-stroke figure we have seen, and 2-stroke figure engine we can see it is very simple compared to this. Number of components here are very less compared to that, and basic most important is we don't have valves here. You can see here we don't have a valve, inlet valve and exhaust valve. Only ports we have. One is inlet port, one is exhaust port, and third is a transfer port over here. So now let us understand the process is same. The suction will happen, compression will happen, expansion or power will happen, exhaust will happen. But how it will happen without valve, let us understand. At this particular figure, if you see the bottom portion of my piston, this line, it is covering exhaust port. So flue gases cannot go out as it is in off condition, closed condition. But you can see here this inlet port is in open condition. So let us understand, when my piston is at top dead center, extreme position of vertical position, my inlet port is open. So fresh charge, let us understand only petrol engine, so that I will use air fuel mixer. Air petrol mixer will get inside. When it is getting in, already here some flue charges you are having over here. So when it will get in, it will be stored over here. In case of 4-stroke engine, your air fuel mixer getting in above the piston, while in case of 2-stroke engine, it is getting downward direction of the piston. So this is what basic difference is. First one, so it is getting in. Now same time you can see here the red color line shows that the compressed fuel is getting in upper side, but here it is a blockage, so it is compressed. Only one is opening over here. Now piston will move downward direction. When piston will move downward direction, unless this portion, top edge of this will come to this, exhaust valve is open condition. So piston is moving downward direction. The fresh charge here will be compressed. So compressed charge is shown by the red color. So next figure we will see that now piston is moving downward direction. See, it is getting in here. Now piston is moving downward direction. So arrow indicates blue color line. Now at this position of piston, my exhaust port is in closed condition, and inlet port is also in a closed condition. So whatever charge I have here, as piston is moving downward, it is compressed. So compression process will happen over here. After this compression process, now when you come to this one, now my piston position is somewhere over here, so that you can see here my exhaust port is open, but inlet port is in closed condition. So when exhaust port will open, the flue gases over here will go outside. So blue color line shows that the flue gases are going out. Simultaneously the compressed charge in red color is moving up. So two things simultaneously happening over here is the exhaust gases are going outside, and compressed air fuel mixer is getting up into a system. When it will move down again, it will move down here, the fresh charge will come over here, and piston will start moving upward direction. When piston will start moving upward direction, then spark will ignite, the combustion process will take place, and the cycle will be repeated. So this is the construction of 2-stroke petrol engine. Same will be here, same will happen in case of diesel engine, but instead of spark plugs we will have the fuel injector. So this is 2-stroke engine. The basic advantage of 2-stroke is, in case of piston movement, if you see piston top dead to bottom dead center 1, and bottom dead center to top dead center. So in a 1 revolution of crankshaft, I am getting 1 power stroke. While in case of 4-stroke engine, suction, compression, power and exhaust, so in a 2 revolution of crankshaft we are getting 1 power stroke. So you can compare in this way: 2-stroke, 1 revolution of crankshaft, 1 power stroke, and in case of 4-stroke, 4 movement, up down movement, 2 revolution of crankshaft, we are getting 1 power stroke. So 2-stroke engine are more powerful compared to 4-stroke engine, and power stroke is more. Second is, it is simple in a construction. As number of valves are less, mechanical efficiency of this engine is very high. But with mechanical efficiency, the thermal efficiency of this will be lower compared to 4-stroke engines, because when compressed charge is getting up, the exhaust valve is open here, so it is a mixing of over here. The flue gases are getting out and fresh charging is getting in, so some amount of flue gas will remain inside and it will mix with this. So thermal efficiency of 2-stroke engine will be less compared to 4-stroke engine. Now different cycles. You can see here the Otto cycle and diesel cycle. Otto cycle is petrol cycle. When your engine is a petrol engine, how its pressure and volume will change. So we are plotting here the PV diagram, pressure and volume diagram for petrol, and same is a diesel. What is the difference? Let us understand. The first figure says that is a compression suction stroke or inlet stroke. 0 to 1 it shows. So on PV diagram, if you plot, 0 is somewhere over here. When it will move in downward direction, piston moving downward direction, suction will take place. So 0 to 1 is a suction stroke. 1 to 2 compression stroke. So 1 to 2 your pressure is increasing. You can see on PV diagram your P1 to P2, if you plot, the pressure is increasing and volume is decreasing. So 1 to 2 is this process. Now 2 to 3 process, at constant volume heat addition happens. So in Otto cycle, spark will ignite and combustion process will take place. So heat addition process in case of Otto cycle happens at constant volume process. So 1 to 2 process is a heat addition process at constant volume. Now 3 to 4 is power stroke. When it is a power stroke, or we call it expansion stroke also, so pressure is decreasing, you can see here, and volume is increasing. Now 4 to 1 is exhaust, at constant volume exhaust. So 4 to 1, when piston is at bottom dead center, your exhaust valve will open, so flue gases will go up, and 4 to 1 is again continuous exhaust stroke. So now the volume is decreasing and flue gases are going in outside. So this is the PV diagram for Otto cycle. One is straight line, means constant pressure, suction, then compression, heat injection, heat inlet, expansion and exhaust. This is the ideal cycle, the ideal PV diagram for Otto cycle. But when we put into an experiment or actual condition, when you look, your diagram is something like this. So it is not actually a straight line, but you will think the diagram is something modified. So actual diagram in case of PV diagram, if you take bike or a car, it follows this kind of curve. So this is Otto cycle. Now come to diesel cycle. If my engine is a diesel engine, what will happen? Same thing, suction, compression. The difference is over here. In this diagram, the heat addition happens at constant volume, while in case of diesel engine, the heat addition happens at constant pressure. Same. Then after the expansion and exhaust is same. So this is what basic difference in Otto cycle and diesel cycle is. Heat addition happens at constant volume in Otto cycle. Heat addition happens at constant pressure in diesel cycle. And if it is dual cycle, then it will be a combination of this and this. So diagram will be heat injection at constant volume, and then diagram will be like this, horizontal line, and then it will follow like this. So these are the two basic cycles, Otto and diesel cycle. Performance curves. So now if my engine, I am using engine, how it is efficient, the efficiency we can calculate, that is what output we are getting and what input we are getting. So if mechanical output I am getting, we can measure in, and fuel inlet, what amount of fuel we have injected into that, then the ratio of this mechanical work output upon fuel injection input will give you the efficiency of this. We will discuss more about this efficiency, how to measure different parameters on next lecture. But let us revise fastly what we have discussed in this lecture. As classification, we have discussed in a different classification. Then different component we have discussed, that different component, how they are using, what is the position of that, and what is the utilization of that. Then we follow the 2-stroke and 4-stroke engine. Let us revise what is 4-stroke engine is. In the power stroke you will get in out of 4-stroke. The 4 strokes are suction, compression, power and exhaust. While in case of 2-stroke engine, everything will happen, suction, compression, power and exhaust, but it will be in a 2 revolutions. So piston will move top dead to bottom dead and bottom dead to top dead. The 2-stroke engine is finished. While in case of 4-stroke, there will be a movement of 2 times. So revolution of crank in 4-stroke is 2 times and 1 power stroke. While in case of 2-stroke engine, in 1 revolution of crankshaft, we will get 1 output power stroke. Then we discuss about this cycles. In case of Otto cycle, as we have discussed that Otto cycle, suction, compression, expansion and exhaust will happen, but the most important parameter is at what condition heat input will happen. So we have seen that in Otto cycle, at constant pressure, constant volume heat addition happens, while in case of diesel engine at constant volume heat addition happens. And lastly, the performance. If you want to measure the efficiency of this engine, we are having number of terms. One is mechanical efficiency and thermal efficiency, like that, but we will discuss first thermal efficiency and then mechanical efficiency. So thermal efficiency, you can calculate what mechanical work output you are getting and what is the fuel input. If you take this ratio, then it is called the efficiency of engine. Thank you.